Aubrey and Hallie. Aubrey and Hallie, okay? We are starting a new chapter, and we are in chapter 7. So Hallie and Aubrey, I guess you both will need to get a new book from me, okay? Because this is the start of volume 2. I know that you guys have chapter 12, but you'll need the whole book, okay? All right, 7-1. First thing I want you to write down off to the side. This is important. Write it down. The number of sides for a polygon. They have special names. Here they are. Okay, put this in the little bit off to the side on the right side. I'm ready to start. You hurry up. Number of sides. If a polygon has 3 sides, it is called a triangle. If it has 4 sides, it is called a quadrilateral. Not necessarily a square or a rectangle, but a quadrilateral? I don't know. What's the title of the section? Quadrilateral. I don't know why I can't spell today. Quadrilateral. Okay. If it has 5 sides, it is called a pentagon. If it is 6 sides, it is called a hexagon. If it has 7 sides, it's called a what?
Heptagon.
How do you know that? Heptagon. If it has 8 sides, it is called a octagon. Right? Are you writing this down? Octagon. Octagon. If it has 9 sides, it is called a nonagon.
How'd you know that?
If it has 10 sides, it is called a decagon. If it has 11 sides, it is called a no. No. It is called a hendecagon. Cagon. Hendecagon. I don't know why hen. I have no idea. 12 is called a
Dicon.
dodecagon. 13 is called a 13gon. 14 is called a 14gon.
So why can't 11 and 12 be 11?
Okay, I don't know. Because typically after you get 12 sides, it is like very smooth on the edges anyway, and it really just resembles a circle at that point. Okay, that makes sense? So there's that. Okay, so anything 13 and beyond is called a 13gon, 14gon, 15gon, whatever, okay? Now, I also want to introduce something to you. We have something called a regular and irregular. Let me put little stars by them. Regular and irregular. A regular and an irregular. Okay? All right? Okay, for example, if I have a pentagon that has 5 sides, I will draw a regular pentagon. I will try to draw a regular pentagon. And I will draw an irregular pentagon. 1, 2, 3, 4, 5. Yeah. Regular, irregular. What's the deal with regular?
All sides and angles.
All sides and angles are equal. So like this guy and this guy and this guy and this guy and this guy are all the same, and same thing with the sides. They are all the same. That is a regular pentagon. A not regular pentagon or an irregular pentagon, like it might look like all those sides are the same. I don't really know, but I know for sure that this angle is not the same thing as those, right? Okay, so that is an irregular guy. There is also another name that goes along with this guy that is special, and that's different than this.
Is it a rhombi?
No. A rhombi only has 4 sides. This is convex, and this is concave. Okay? Have you heard that before? Convex and concave? Convex and concave. Okay? One of the sides is caving in. The rest of it, is all nice and good. So, regular, irregular, convex, concave, all of the things, right? Okay? All right, so there's that. Are we good? Did you get all that written down? Okay, naming polygons is going to be a thing, all right? Okay. All right. Here we go. Let's talk about this shape right here that's in the middle of the page. Okay? It has how many sides? 5 sides. It is a pentagon. Regular or irregular?
Irregular.
It is irregular. He is a pentagon. It's an irregular pentagon. All right, now, here's the deal. Okay. Specifically, what I want to know is what all of these angles inside of this pentagon add up to be. Now, for one thing, are all of those angles going to be equal in measure? No, like this one is an acute angle and this one's an obtuse angle, right? So I know for sure like those are not the same, right? So we know that here's irregular, but I want to know what all of those angles add up to be. Okay, real quick. In a triangle, how many degrees are all of these going to add up to be? 180. Do you know how many degrees a rectangle or a square have? 360. Do you know how many a five-sided figure has?
540.
540. How like what's the rule?
Add 180.
You add 180 each time, okay? Now, here's really the rule. Are you ready for the rule? If you have a five-sided figure like a pentagon, are you looking at this? I just picked one of the vertices, and I started separating this pentagon into triangles, right? Okay? If it has five sides, how many triangles will it have? 3, right? You see? Like I've separated them into 3 triangles. Like I've drawn things, whatever. Here's triangle 1, triangle 2, triangle 3, right? In that pentagon, okay? And each one of those triangles contains 180 degrees, right? So I can get away with taking 3 times 180. And that will tell me how many each of these angles add up to be, right? Now, let's say I'm dealing with a 7-sided figure or a heptagon, right? A 7-sided figure, I don't know, don't draw this down. 1, 2, 3, 4, 5, 6, 7. That's a 7-sided figure. How many triangles will a 7-sided figure have?
7 times 180.
No.
5.
There's a triangle, there's a triangle, there's a triangle, there's a triangle. How many triangles will a 7-sided figure have? If it has 7 sides, it has 5 triangles. So what is the rule?
Number of sides minus 2.
Yeah, it is the number of sides minus 2. Let's go down here to this little theorem 7-1. The number of sides minus 2 tells you how many triangles it will have. Each triangle has 180 degrees. So I take that many sides times 180. Like here for this pentagon, I took 3 times 180. Here I'm taking 5 times 180, right? It will have 2 less triangles than the number of sides, yeah? Okay? Good? Okay. Moving on. Example 1. Shh. Quit. I'll just kick you out. I'm not in the mood today. Example 1. How many sides does this guy have? 5. Okay. So this angle is 142. This is 2x. This is also 2x. It looks like he's kind of symmetric, right? Okay, that's 3x plus 14. This is also 3x plus 14. But it's a 5-sided figure. Okay? If it has 5 sides, and I separate him into triangles, how many triangles will he have? 3 triangles. Okay? And each of the 3 triangles is 180 degrees. So if I do 3 times 180, that is how much? 540. So that means if I add all of these together, it will end up being 540, right? Equals 540. Okay, so let's add some stuff in our head, right? Okay? Can you put the x's together? 2x, 3x, 2x, 3x, 10x? Okay, 10x. 14 plus 14 plus 142.
I have no.
Yeah, you do.
14 plus 14 plus 60.
170? Yeah?
I knew that.
Okay. All right, now let's solve for x, right? If I subtract 170, what's 140 minus 170? 10x equals, I don't know how much.
5,
No.
4.
370. So x is how much? 37. Okay. I shouldn't put degrees on the end of that. X is 37. But they want to know, find the measure of each interior angle of the pentagon. All right, so x is 37. I know that the top angle is 142. That's given to me. But if these two guys are 2x and x is 17, then, or x is 37? 37. So that guy is how much? 37 times 2. 74, I think. 74 degrees, 74 degrees. Okay? If I plug 37 in here, what's 3 times 37 plus 14? 110. 110 degrees, 110 degrees. There they are. And all 5 of them should add up to be how much? 540. Awesome. There you go. Okay? All right. That was example 1. Okay, I'm moving on quick. Let's go example 2. Oh, my heavens. Penny is building a house using a floor plan that she designed. What is the measure of, what does this thing say?
ABC.
What?
Angle.
Angle ABC. Which angle is angle ABC?
That one.
The angle of ABC.
Angle B, ABC. This angle particularly right here. They want to know how much that is. Okay. This shape right here is how big? That's a 6-sided figure. He is a hexagon, okay? Now, I need to figure out if it's a hexagon and it has 6 sides. Shh. And I separate him into triangles. How many triangles will he have? 4 triangles, right? 2 less. 4 times 180, you said, was 720?
Divide by 6.
Divide by 6. How do I know that they're all the same?
Because they're equal aligned.
Because this is a regular hexagon. All of those are the same and all the angles are the same. So, 720 divided by 6, angle B is how much? 120 degrees. Yes? 720 divided by the 6 angles. 20. So each of those is 120, 120, 120, 120. Got it? Yeah? Right? Okay. Good? Happy with that? That was example 2. Example 3. Here we go. The measure. Go. Move on to example 3. Go. Example 3. The measure of an interior angle of a regular polygon is 144. Now they say a regular polygon. Shh. Okay. I don't know what's happening over here. And you look the guiltiest. So guess who's getting kicked out of my room first, Mr. Guilty Look? I'm sure more are guilty than just you. Yeah. Okay, fix it, do whatever. Okay, let's be done. All right, here we go. The measure of an interior angle of a regular polygon is 144. What does regular mean?
Equal.
They're all the same, okay? Now, I have no idea. Oh, they have this little guy over here, right? We just filled this out, okay? A regular polygon. I have no idea how many sides this regular polygon has, right? But I know that each one of them is 144. Yeah? 144, 144. This is going to be the hard part. You're not going to know what to do because you're not listening. 144 is each angle, okay? I want to know how many sides that thing has if each angle is 144.
Well, it's not a polygon.
Minimum of 5.
A minimum of 10.
6 sides has is 120 degrees. And the more sides you have, the bigger the angles become inside, right? Okay? So it's got to be bigger than 6. Might be 7, might be 8, I don't know, right? Okay? So how do we figure out, real quick, how do we figure out how many degrees are inside of here?
We find how many sides there are.
Okay, the number of sides, let's call that n, right? N minus 2 tells me how many triangles it has. Hold on, shh. N minus 2 tells me how many triangles it has. And then what do I do with that number?
Times 180.
Times 180. That tells me it's all inside of there. And then what do I do to find out what each one is?
It equals 1.
Shh. Hold on. How do I figure out what each one of them is? I take the total number of degrees inside and I divide by what? The number of sides, which we call n. And that is going to be equal to how much? 144. Do you see what I just did? Okay. So then n minus 2, right? That's going to tell me how many triangles I have times 180. I'm going to divide by the number of angles that I have and equals 144. Okay. Now, I have to solve this for n. The n's don't cancel. I can't cancel like that. What should we do? This is the hard part. Not yet. I'm going to multiply this n over, right? Okay, that's 140n. Also,
Distribute.
144n. I want to distribute this 180 through. What's 180 times n? 180n minus 360. Okay, then what?
5.
Not yet. Add what? I don't want to do that. I'm going to subtract 180. We're going to end up with negatives, but it's going to be fine. I'm going to subtract 180n. So I have negative 360 equals negative. Do some math. 36n. Yeah? And divide by negative 36. So if each angle is 144, how many sides does this thing have? 10 sides. Okay, so here's the deal. I'm going to write you a little cheat sheet here. In order to figure out. Are we done writing that down? Can I move to a different spot? Okay. I'll give you a second. Because you'll have a problem like this on your homework assignment, I know. And you're going to be like, what the heck do I do? Okay? All right, so here's your little cheat sheet. Whatever your number or whatever your angle size is, I'm just going to say the angle. If they give you one angle,
Where's this at?
you take the number of sides minus 2, that tells me how many triangles I have, and you multiply that by 180. And then what do?
Divide by n.
Divide by n, and that's equal to whatever angle they give you. And then you solve it backwards, and you find what n is. Or you can guess and test, but it's probably going to take you a little longer to guess and test. Okay? This is the process for finding what one angle is, right? And if they give you the angle, you just work backwards. Okay? So maybe write this guy down, because that will help you solve that. Got it? Okay, all right. Okay, everything that I just told you. Everything that I just told you was true for interior angles. Write this down. Interior angles.
Exterior angles are dumb.
Okay. No, exterior angles are easier. Interior angles are dumb. Okay, let's say I have 1, 2, 3, 4, 5, 6. That's a 6-sided figure, right? Okay. How do I figure out how many degrees are inside of that 6-sided figure? How many triangles will that 6-sided figure have? 4, and I take that times 180, and that is how much? 720. So the degrees inside of that 6-sided figure is 720, because you take n minus 2 and you multiply by 180. That is 4 interior angles. Interior means inside. All of these angles inside here add up to be how much? 720. Okay? Now we're going to talk about exterior angles. Your homework assignment is going to ask you for both. Make sure you know which one they are doing, because they are both very different. Here is a 6-sided figure, and it kind of looks like a little pinwheel, right? They have extended, it looks weird, I know. They have extended each side out to make these exterior angles. Now, are all of those exterior angles going to be the same measure? No, only if it is a regular polygon, right? Okay, now, here is the deal. Are you ready? If I have a triangle, don't write this down, but just watch. If I have a triangle and I make the little pinwheels off of him, right? Those angles are going to be really big. If I make a 4-sided figure, okay, and I do the pinwheels off of him, you're not listening. And I add those all together, those are slightly smaller. When I get to a 6-sided figure, now my exterior angles are getting to be a little bit smaller, right? Okay? Here's the trick. No matter how many sides, I don't care if you have a triangle, if you have a 4-sided figure, if you have a 6-sided figure, no matter what, all of the exterior angles, these guys, will add up to be 360 no matter what. No matter how many sides you have. It is not different like it is interior angles. Interior angles depends on how many sides you have. Exterior angles, they will all add up to be 360 every single time.
Dismiss the junior high cheerleaders that are here today.
Okay, so example 4. They give me this shape. This is a what?
Triangle.
A quadrilateral, okay? Inside that quadrilateral, it has 4 sides, right? How many triangles will that 4-sided figure have?
2.
2. And I take 2 times 180, and that is how much? 360. So all of these guys add up to be 360. Regardless of how many sides it has, though, the exterior angles are going to add up to be how much? 360. It's always 360. No matter what. Okay, so how do I figure out what x is?
Equal them to 360.
Okay, what is 6 plus 9 plus 12, or plus 2? 17x plus 139 equals 360. Let's subtract 139. What is that? Yes, you do.
413.
What?
What?
No. 121. 221. 221. You're right. 221.
I told you.
Divided by 17 is how much? 221 divided by 17. What does that make? 1, 5, 51, 13. Yes.
You know,
I think it's.
Nope, it's 13. X is 13. Find the value of x. We're done. Okay, good? All right, now this guy right here
That one.
has how many sides? Regardless of how many sides it has, this angle plus this angle plus this angle plus this angle plus this angle adds up to be 360. It's always 360 for the exterior angles. Always. The interior ones will end up being different, but the exterior ones always will add up to be 360 always. Now, okay? For those of you who are not like completely snowed right now, are you ready for this? Okay, I'm going to show you a little trick. For you people who can handle this, are you ready? Okay, for you people who can handle this.
You people.
You people.
You people.
Okay, let's say this is my, how many sides does this have? 6-sided figure? Okay, all right, ready for this?
Looks like a Beyblade.
Here's what I can do. I can, let's say I want to know how many degrees each one of those is, and I know this is a regular polygon. Ready? Hold on, just wait a second. Let's talk about the exterior angles. There are 6 of them, but what do all 6 of those add up to be? 360 divided by 6 is 60 degrees. So each one of these is 60. So what is that one?
That one's 120.
120 because they are on a straight line. Do you see that? So there's another way of getting to that might be even faster, right? If it's a regular polygon. Does that make sense? Okay? All right. If that was confusing, ignore that. But there is that, okay? All right, here we go. Find the measure of each exterior. Circle that. Circle the word exterior. Because you got to make sure you know which one is which. Exterior angles of a regular dodecagon. What's a dodecagon?
10.
12 sides. Okay? So I have a figure with 12 sides, and they want to know an exterior angle. If it has 12 sides, what do all the exterior ones add up to be?
18.
360. Okay? And it's regular, so you know all of them are the same. So I take 360 and I divide by 12, and that is 30 degrees. See, each one of those is 30 degrees. So, hold on. Hey, wait a second. Listen. If each one is 30 degrees on the exterior, what's each degree on the inside? 150, right? I can find that out pretty easily. Yeah? Okay, there you go. You are going to do numbers. I don't know. We're on, what page are we on? 409? 409. Page 409. Ooh, hey, what are we doing over there? Geometry. We are on 7-1. Page 409. 1 through 4 all. No, I'm not done. 1 through 4 all. And 6, 8, 10, 12, 16.
Whoa, that's a big jump.
Give me a sec.
Oh. I knew we were doing 2 and 4, but I had no.
18, 20, 22.
I did all the.
Still going?
That's it.
Oh,
Wait, 6, 8, 10, 12.
Jacob.
Wait, let me see here.
6, 8, 10, 12, 16, 18, 20, 22.
6,
Good math.
Well, that's an awfully weird.
8,
3 parts.
10, 12.
Okay, 6 through 22 evens. Skip 14. Whatever.
So all the evens.
I don't know.
Wait, what?
Because.
Yeah.
22.
6 through 22. Evens. Skip.
There you go.
Seems like a lot of work you working.
All right, use your time to work. This stuff is pretty easy, but make sure you know whether they're asking for interior or exterior. There you go.